Okay, in this video we're going to convert from our vector notation with the x and y parts, I and j, to our vector notation with the magnitude and direction, polar coordinates. So let's start with a little practice. Naming vectors using vector notation. So we have three vectors here. Vector A is 5i minus 7j. Vector B is minus 4i plus 6j. And vector C is 3i plus 7j. So go ahead and draw a coordinate plane and then draw out these combinations of vectors. And go ahead and pause the video and check your answers in a minute. Okay, so the black one, 5i minus 7j, so positive 5 in the x direction, minus 7j in the y, and that's my resultant, r. 2, minus 4i plus 6j, so minus 4i, so I'm in the negative x direction, plus 6j in the positive y direction. Then 3i plus 7j, so positive 3i in the x direction, plus 7j in the y. And that's what I get. So that's how we name the vector components using vector notation. Now let's convert it. So when I start with a vector r that has a magnitude of minus 6 meters in the I, plus 9 meters in the j, again, I always start at the center of my origin, and I draw the first vector, my minus 6 meters. The I is the x direction, negative tells me to the left, then plus 9 meters times j. So that is 9 meters positive y, which is my j unit vector. Now to convert to the overall magnitude and direction, usually we try to draw these in red. I haven't been doing a good job of color coding. So we'll call that value r and that value the angle. This is like my x and my y component. Okay? Again, we use a little trig, but this time we use, this is right triangle trig, but we use some different tools. Now, I know two sides, I want to find the third. I can use Pythagorean theorem, where r squared equals x squared plus y squared in this case. Now when I'm doing this, the fact that this is a negative 6, don't confuse the direction negative with the length of the side being negative. Because it's really not a negative 6 meter length side, it's just 6 meters to the left. So when you're doing your actual calculations here, you just use the absolute value. Really it should be absolute value of x plus absolute value of y. And that'll prevent some silly mistakes where you get an r less than one of the lengths of the side because you subtract one of the squares. So let's do absolute value of minus 6 squared plus absolute value of 9 squared. Again, if you just want to drop the negative, that's totally fine. Equals r squared, so we have 36 plus 81. So let's do, so that's 110, 117, square root 117 equals, gotta square root it to get the r, 10.82 meters. So this is the magnitude of the vector, but I'm not totally complete with just the magnitude or the length from beginning to end. I also must include the direction. So to find theta now, I got to use some inverse trig, and I'll usually use the tangent function because I'm given the opposite and the adjacent side. So I know that the tangent of whatever that angle theta is equal to the opposite side over the adjacent, the ratio of these two lengths. Okay, so it's just a value, 9/6. How do I solve for angle when I'm inside one of my trig functions? I have to apply the inverse tangent. Don't just divide by tangent. Tangent's a function that you need to invert. So the inverse tangent of theta, I do the same to both sides, inverse tangent of 9/6. So here I'm left with just the angle equals the inverse tan of 9/6. Again, make sure you're in degree mode. If you're not sure, on the TI 83 and 4, there's the mode, radian degree. On the 89s, I'm not so sure. So in this case, the angle is 56.3 degrees. So am I totally done? No, because I got to tell 56.3 degrees in what direction, right? Where do I measure that 56.3 degrees from? And I've measured it from the negative x-axis, which is our west, towards the positive y, which is our north. So I'm going to call this north of west. So the full way of writing this vector out in this notation is magnitude 10.82 meters at 56.3 degrees north of west. That's my direction. And that's how we can convert from unit vector notation with the i's and the j's, the x and the y. Remember, this is x, this is y, to overall magnitude length from here to here at whatever that angle is.